In this example, we'll look at and see what happens when you multiply two binomials that are the same, except one has addition and the other has subtraction. We'll begin by using our usual distribution foiling process. So in part A, we have x plus 4 times x minus 4. The usual process would be multiply the first terms, x times x is x squared, multiply the outside terms, x times a negative 4 is a minus 4x, multiply the inside terms, a 4 times an x is a positive 4x, and multiply the last terms. 4 times a negative 4 is minus 16. So in our initial step, nothing seems different than a usual foiling problem. And like many examples, the two middle terms are like terms, so we'll be able to combine them and reduce them. But what is different is that one is a positive 4x and the other is a negative 4x. And when we combine 4x with a negative 4x, they completely cancel. So not only are they like terms, they're also opposites. And when we add them together, they cancel each other out, leaving us a final answer of x squared minus 16. Looking at part B, again we begin using our usual foiling process. 3y times 3y is 9y squared. 3y times a positive 2 is a positive 6y. Negative 2 times 3y is a minus 6y. And a negative 2 times a positive 2 is a negative 4. Again, the two middle terms are not only like terms, they are opposites. 6y minus 6y is going to cancel, leaving us just the final answer, 9y squared minus 4. A more general way to present what's happening here is to try to eliminate all the unnecessary variables or specific numbers and just use a's and b's and see what happens when we multiply a plus b times a minus b. From the first two examples, we should have an idea what's going to happen here, but let's work it out step by step. A times a is a squared. A times a negative b is a minus ab. A b times an a is a positive ab. And a b times a negative b is a minus b squared. Again, we have the same thing happening that's happened in the first two examples. One term is a minus ab, while the other is a positive ab. Those are opposites, and when you add opposites together, they cancel out. So our final answer reduces down to a squared minus b squared. So the general rule that we'll want to remember is when you multiply a plus b times a minus b, it reduces down to a squared minus b squared. Now if we ever forget this rule, we can go back to the standard distribution and foiling and we'll get to the same answer. But if we can remember this, it might make some future problems we have a little bit easier. The one other thing to point out before moving on is a vocabulary word. When you have two binomials that are the same, except one has addition in the center and the other has subtraction in the center, those are called conjugates. Conjugates can be very useful for a number of different places in mathematics. For us right now, we just see that when you multiply two conjugates together, the outside and the inside terms cancel, and it just gives us the first term squared minus the second term squared. On part D, we want to multiply 4p squared minus 9p times 4p squared plus 9p. Before jumping into just foiling and distributing, I recognize that the two binomials are conjugates. They are identical except one is addition and the other has subtraction. So instead of approaching this from a foiling perspective, we're going to try to apply the rule that we just learned. The rule we just came up with is that a plus b times a minus b will simplify down to a squared minus b squared. In applying that pattern or that shortcut to this particular situation, we need to recognize that 4p squared is our a for the pattern and 9p is our b. So when we go to write this out without the foiling, it's going to be the entire first term squared, 4p squared quantity squared, minus the entire second term squared, 9p squared. The parentheses around the 4p squared and the 9p are critical because that outer exponent of 2 has to apply to the entire term, both the 4 and the p squared, and in the back it has to apply to the entire term, both the 9 and the p. Using our exponent rules for multiplication, I'm going to square both the 4, which gives me 16, and the p squared. P squared quantity squared is p to the 2 times 2, or p to the 4th. It is important to note that because the subtraction is outside the parentheses, the subtraction is not getting squared and will continue to be subtraction, but I will square everything inside the parentheses. 9 squared is 81, and p squared is p squared. So our final answer becomes 16p to the fourth minus 81p squared. You might find for some examples it would have been more comfortable to distribute using the foiling process, but it is definitely worth the effort of practicing this process to help you in future situations. In part E, again I recognize we have the conjugate situation happening. We have the quantity 3/5 t plus 2/3 times the quantity 3/5 t minus 2/3. So the binomials are the same except for the sign, addition versus subtraction. In this situation, my 3/5 t will be my A, and my 2/3 will be my B. So the pattern is usually A plus B times A minus B is A squared minus B squared. That will become, in this situation, 3/5 t squared, that's my A squared, minus 2/3, that's my B squared. Again, I'm going to have to remember to square both the 3/5 and the t, and in the back square both the 2 and the 3. So 3/5 squared is 9 over 25 t squared minus 2/3 squared is 4/9. If you practice and become comfortable with this shortcut, the product of conjugates, it will not only help you in the multiplication that we're doing now, but when we move on to something called factoring, it will be extremely useful to know this shortcut at that time as well.